So hello everyone, this is lecture 9 for the nuclear physics. In the last lecture we were discussing about the radioactivity. So before moving forward, first we need to discuss some questions. So let's see. In a mass spectrometer, a single charge positive ion is accelerated with a potential that is 1000 volt. It then travels through a uniform magnetic field for which magnetic field is given 1000 cos and is deflected into circular path of radius 18.2 centimeter, and we need to find what is speed of that ion, mass of the ion and mass number of the ion. So see, potential is given 1000 volt, B is given 1000 Gauss, and radius is given 18.2 centimeter. So we know that potential will give the kinetic energy to the ion. So that potential multiply the charge will give you that energy must be equal to the kinetic energy half mv square. This denotes speed and this denotes potential. So from here and now see, if magnetic field is present, then charge will go into the circular motion, and that is because of the centripetal force given by the Lorentz force, that is qvb must be equal to mv square over r. This is centripetal force. Now here both are speed. So now just mv square equal to 2qv. So in place of mv square we'll write 2qv. This is potential. Now q will cancel out, and from here you can find the velocity, that is this. So that will be 2v divided by br. So b is given, r is given, v is given. Just find the value, that will be this. And now if you have the velocity, second they ask the mass of the ion. So from here you can find that is mass equal to qv divided by v square, 2qv divided by v square. So just substitute the values, we already find it here. So this will be your value. Now mass number is simply means you need to write the mass in the atomic mass unit. So that will be mass divided by 1.67 to 10 to minus 27. So that will give you the answer in the AMU, and that will give you the mass number, that is 16, around 16. Now next question is difference in the Coulomb energy between the mirror nuclei 24 Cr49 and 25 Mn49. So it is 6 mega electron volt. Find the radius of the Mn. So both will have the same radius. So we know that Coulomb energy difference is simply equal to this. We know this formula, we already derived it. Not derived, we just read it. So this is already given. So this is your energy, and we know the value of this. If it is not given here, then we will take it as 1.44 and just put the Z1 and Z2. This is your proton or the atomic number. This is 25 square and 24 square. So this will give you the radius. You can just find it by calculating. Next is in deep inelastic scattering, electrons are scattered of proton. So we need to find the proton, means we need to determine the proton structure. So we are just throwing the electron beam on it, and we need to find the approximate energy of the electron that is required to find the structure of proton. So we just radiating this electron beam on the proton. So what is energy required of electron to find the structure of proton, minimum energy? So lambda must be equal to 2 radius of that target size. So that is radius proton. So radius proton is 1.2 Fermi. That will give you the lambda. So this lambda is required. Now you can find the energy how. Lambda equal to h upon p. So p is simply h upon lambda, and pc will be given by this. So this energy is very much larger than the rest mass energy of electron. So that's why this is the relativistic case, and we can just find the total energy, that will be around pc, because this is very small, that is 516 mega electron volt. So this is the energy required for the electron. Next question is, a nucleus has a size of 10 to the minus 15 meter, that is Fermi. Consider an electron bind within a nucleus, means we need to find an energy of this electron which is bind inside the nucleus. So what is the energy of that electron if it is inside the nucleus? So the 2r must be equal to 10 to the minus 15 meter, that is a size. So we know this is given size is 10 to the minus 15, that is delta x. If we use the uncertainty principle, then delta p will be delta x. So h cut by 2 delta x. So this will be delta x is simply 2r. This is 2r, and just substitute the value of this 2r equal to 10 to the minus 15 and h cut c, and you will find the value will be this. And this is again very much larger than the rest mass energy of the electron. But see, this is the means total energy will be this for the electron inside the nucleus. But in the beta decay, we will find that when the electron is emitted, that electron have energy around 800 mega electron volt. So it is outside, it has 800 mega electron volt, and it is given that inside the nucleus it must be this. So that's why this is a proof that electron can't exist inside the nucleus. It is produced or constructed outside the nucleus. When it is emitted, means when there is decay, it is produced or constructed outside the nucleus. Electron will be constructed outside, that's why. And this is the reason, because outside we have energy that is around 800 mega electron volt. If electrons are trapped inside the nuclei, they will carry 100 mega electron volt, around 100. However, in beta decay we got electron carrying maximum energy of 7 to 8 mega electron volt. It means electrons are not pre-existing inside the nuclei but created only at the time of emission. So you must remember this can be asked in the interview. So this is a very important task, means point, that why electron can't exist inside the nucleus. Next is electrostatic energy of Z protons uniformly distributed throughout a spherical nucleus of radius r is given by this. So there are Z protons which are uniformly distributed around the spherical nucleus, and their energy is given by this formula: 3Z Z minus 1 e square 5 by 4 pi epsilon r. Measured mass of neutron, they measure the mass, that is for neutron and hydrogen, nitrogen, oxygen are given as this. So all masses are given. Respectively given that the radii of both the, means these are the mirror nuclei, and radius must be remain same. So we need to find the radius of either of these nuclei. Okay. So how can you find this? So we already discussed this method also. Means nitrogen is decaying into the oxygen and beta negative particle with the antineutrino. So delta EC, that is Coulomb energy difference, must be equal to this. So this is the formula already given, so you must use this formula. So that will be this. Now this is Z1 minus Z2. So Z1 is this and Z2 is this. So this will be this. Now we have this delta EC, that will be equal to this. Now we need this energy to find the radius. So how can we find the energy? So we know from this process the difference between the binding energy must be equal to this Coulomb energy difference. So binding energy difference is simply this binding energy of this minus binding energy of nitrogen. So binding energy of oxygen is given by sum of its constituent particles, that is the proton and neutron. Proton is 8, neutrons will be 7. So that mass minus the total mass of the nuclei of oxygen, that will be this. So this is the binding energy of oxygen minus the binding energy of nitrogen. That will give you difference, will give you delta E, and just put that energy equal to this thing, and you can calculate the R very easily. Next and the last question is, a neutron of mass, this mass of neutron is given, is moving inside a nucleus. Assuming the nucleus to be cubical of size, so nucleus size is cubical with impenetrable walls. So take H, that is Planck's constant given, 10 minus 34. So this is the approximate size given. Find the estimate of the energy of the neutron in mega electron volt. So we need to estimate the energy of the neutron. So these are the estimations, that why we are taking mass as only the powers we are taking, 10 to the minus 27, H is minus 10 to the minus 34. So we know in the quantum mechanics, if it is this cubical type structure, so you will use the direct formula. Energy is given by this pi square square 2 ml square. So see, we don't need to consider this because we need to give the estimation of energy. In the options you will get only some 10 to the minus something. So if you consider this, then take the 1 1 1 and that will be 3, because this is a cubical structure. Otherwise you just need to substitute the value of h square L square and mass and this here, and you will get some energy estimations here. That will be your answer. So that's it for today. Thank you everyone.